This is supposed to be the last lecture on economic growth, and I hope it'll be the first where we get a little bit into depression economics. We want to try to do a bunch of things, but first let me start out with what I hope will be the last logistical commercial. That is the current situation. We don't have more people who want to take the course than we have seats. The only reason that people are not yet in the course is because they're trying to get into a section that's already full. If this is your problem, go up and see Joan Kask in the International and Area Studies office and get it resolved. Otherwise, simply switch your section online and you should be absolutely fine. Right? The waiting list should have cleared by now. We shouldn't have people still on the waiting list. Problem set 2 is due right now in this pile up here at the front. Answers to problem set 2 will go out this afternoon onto the web as soon as I proofread them one more time, because it's really embarrassing to make arithmetic errors in your problem set answers. And yet it always happens that you do so, no matter how many times you've taught the course. And in the future, please write down your name and your section time on your problem sets, because that's going to make it much easier for Dariush Zahedi to get the problem sets back to people in a timely fashion, if he can sort them by the pile of when people are attending their sections. Now, problem set 2. The economic growth parts of courses like this are always regarded as the hardest and most difficult and most confusing. Nevertheless, I'd like to know people's reactions to problem set 2. What do people think of it with respect to the way to spend what really looks like it was the first week of spring here in Berkeley, California? Okay, all right. Point taken. Point taken. I have two reactions. First reaction is that this is supposed to be the finest public university in the world, and we want to keep it that way. And assigning long and hard problem sets is a good way to do that. Second is that yes, that when those of us who teach courses like this get together to gripe and talk and gossip, one of the things that we perennially chew on when we have these discussions is whether we should be including economic growth in the syllabus for this particular course at all, or whether that should be shoved off to another course. Precisely because the material is somewhat harder than the material taught in the rest of the course, and not all that closely related to the material taught in the rest of the course. Greg Mankiw, now at Harvard, kind of got us into this business a generation ago when he wrote a very good intermediate macroeconomics textbook that for the first time moved the economic growth material front and center. Ever since then, pretty much everybody has followed Greg in their syllabuses. It's not clear to me we're doing you a great favor. On the other hand, if we don't teach this stuff in intermediate macro, it then tends not to get taught. And it is very, very important. So I said problem set 3 will go out today, and I'm not sure whether to make it a half problem set or not. It depends on how far I get today. If I get as far as I want to get, it'll be a full 10 problem set. If not, I'm going to take a chainsaw to the text this afternoon, or just after lecture, and chop off the bottom half of it, and postpone the depression economics, the business cycle economics part of the problem set until next week, because you won't have covered enough material. That's my current thinking. I'll tell you at the end of the lecture what it's going to be. Because we are about to start the depression economics unit of macroeconomics, which is right and proper. Right now, the economy's in a near depression, and this course should spend a lot of time on the current situation. But as I go over what I want to do and what the likely pace of events is, it looks as though I'm not going to have time to do enough backing and filling over the financial crisis and its consequences in lecture as I want to. So I'm going to make Dariush and his sections talk about the financial crisis. And for that, I'm going to want you to read alongside the textbook what I think is the single best book on the recent financial crisis and its implications out there that exists. Bethany McLean and Joe Nocera's If All the Devils Are Here. So watch your email box for assignments from McLean and Nocera before your next sections starting, say, next Thursday. Because I'm going to want you to be talking about the financial crisis and about Nocera and McLean in sections, and those discussions will go much, much better if you've read the book beforehand. General Bethany McLean is really great. She's also one of the authors of, I think, the best book on Enron, the Enron scandal of the early 2000s, which is also worth reading. And Joe Nocera may be the best kind of personal financial reporter that the New York Times has ever had. The book gets great reviews. It's extremely readable. It's exciting. It's often financial books are quite boring, even though they involve large amounts of money going places where they shouldn't, which is usually something that perks up our interest. But Nocera and McLean make this thing very, very readable indeed. With that, let me move on to recapitulations. Things that you really should know. And one thing that took me a little bit aback was that the end of the problem set appears to have been a bit harder for you all to get than I thought likely. Which means that I'm going to have to think hard about how to teach this better. I remember back when I was a junior, I had these high-powered physics major roommates while I was a political economy major. And they persuaded me that what I really wanted to do was come along with them to their quantum mechanics course and take it pass-fail along with them on the grounds that they would help me do the problem sets and they would make sure I wouldn't flunk and anyway, it would be amusing to watch me try to deal with the material. I agreed, so I went and I did, and I actually learned some quantum mechanics. And actually at one point derived the base orbital of the electron in a hydrogen atom with the Schrödinger equation. Not that I could do it again today, but it was worth doing. The problem was that after the first midterm, right, the professor, Edward Purcell, the inventor of magnetic resonance imagery, winner of the Nobel Prize in Physics, assorted other things, stood up in front of the class and was really, really depressed because the class's performance on the midterm had, he thought, been really, really awful. Why, he said, one student didn't even know, and then he proceeded to give my failed answer to one of the questions on the midterm. And I almost raised my hand and stood up and said, "Don't worry, Professor Purcell, I'm not a real physics major. I'm just a political economy major who's been kidnapped by my roommates and forced to take this course. I really don't know what I'm doing." But I didn't have the guts to stand up and do that. And so presumably his confidence in his abilities as a teacher were greatly shaken by me. And I'd like to apologize now, which I haven't done before. But seriously, when people are having as hard a time with problem 8, say on problem set 2, as they have, it's time for me to stop and go back over what I expected and what I thought would happen in class. So here is our problem set 8. We have Botswana. We have Botswana in the 1950s, before independence from the British Empire, having an extremely low savings rate and being an extremely poor country. Today, Botswana is a middle-income country, one of the richest countries in Africa. The question that problem 8 is trying to get at is, how was this accomplished? And so this problem 8 has 4 parts, and the first of which asks you to move into an imaginary, counterfactual, alternative universe world to try to figure out what would have happened in Botswana if things had been more or less the same except for growth in the efficiency of labor. How do I expect you to do part A? Well, the first thing I expect you to do is to write down kind of the basic growth equation for what determines output per worker. Or in this case, since we don't think the labor force is moving very much as a percentage of the population, output per capita is going to be a pretty good guide to what's happening to output per worker. And our major determinants of the level of output per worker for an economy on its steady-state balanced growth path are three. First, there's the efficiency of labor, this thing E here at the far right. Second, there's the capital intensity of the economy, the term inside these parentheses. And third, there's the speed with which diminishing returns to investment kick in, the speed with which adding more capital and becoming a more capital-intensive economy really doesn't help you very much because you're adding extra capital that's not very useful. And that depends on this diminishing returns factor. That's this little exponential term up here. And the capital intensity of the economy, well, that's the quotient between the savings investment effort the economy's making, its savings investment share of GDP, this variable S, divided by the sum of the country's labor force and population growth rate, N. How much of your new investment is required to simply get your new workers the capital stock they need to produce at the normal level for the economy. The depreciation rate, delta, this little Greek thing, this D with a hooked tail, how much investment is needed simply to replace the capital that wears out, and this labor product, this efficiency of labor growth rate, G, which you need there because if you have a great deal of growth in the efficiency of labor, that's going to need more capital in order to keep the capital output ratio constant as well. So you write down this equation, and you say, what do we know? And you say, well, we have two dates. We have 1960 and 2010. In 1960, we know what our economy-wide level of productivity is. It's given as $900. We know what the savings share is. It's 6%, 0.06. We know what the diminishing returns factor is. It's 1/2, so you get 1/2 over 1 minus 1/2. That's going to simply drop out. You know what the rate of population growth is. You know what the depreciation rate is. The two things you don't know are what the rate of growth of the efficiency of labor was in 1960 and what the level of the efficiency of labor was in 1960. But you can write down everything else in the equation and do what you can to simplify it and get something that looks like this for 1960. For 2010, well, you know it's on its balanced growth path, so you know this is the form to use for capital intensity. You know the savings rate, you know the diminishing returns parameter, you know the population growth rate, you know the depreciation rate. You still don't know what the efficiency of labor growth rate has been, but you do know that you're moving into this alternative universe in which the efficiency of labor in 2010 is no bigger than the efficiency of labor in 1960. So whatever the efficiency of labor was in 1960, it's the same as 2010, same in 2010. So that means this is your equation for 2010. So at this point, you'll notice you don't have quite enough information to solve these equations for the answers you want to get. And I was taught by my teachers that this is actually the best way to ask students to write down problem sets, or to do problem sets. Because if you don't give them quite enough information, they then have to make extra assumptions, which means they have to think hard about what the equation means. So expect always or often that there'll be one little piece of information missing before you can get your answer, and you're going to have to make an assumption about it. Here, there are two possible assumptions you can make, or two ways you can proceed. The first is to say we've moved into an alternative universe in which we're supposed to assume the efficiency of labor isn't growing between 1960 and 2010. That means we can simply assume that the rate of growth of the efficiency of labor is 0. That after all, it tells us not to grow, that it's not going to grow at all. So we can just substitute 0 in for the efficiency of labor wherever it appears. And if we do that, then this term is simply 1. The efficiency of labor in 1960 is simply equal to this GDP, this overall prosperity term. And we know that the efficiency of labor in 1960 is 900. If we do that, then this term here is 5. We know the efficiency of labor in 1960 was 900. So we have 900 times 5 equals 4,500. We see that output per worker in 2010 is 5 times, or output per capita in 2010 is 5 times what it was in 1960. That's our answer to part A. The second road you could take would be close to the same, a little bit clever, would be to say we have a couple of numbers we don't know in each equation, but suppose we look at the ratio between prosperity in Botswana today and prosperity in Botswana in 1960. We know our output per capita figure in 1960 was 900. We know that we have the same term. We have the capital intensity in 2010 at the top times the efficiency of labor, the capital intensity in 1960 at the bottom when we divide the prosperity in 2010 by prosperity in 1960 times the efficiency of labor in 1960. These two terms cross out. 0.30 divided by 0.06 is 5. And so then we have 5 times these two remaining terms left over from our arithmetic. And if we're just willing to assert that the rate of growth of the efficiency of labor is the same in 2010 as it was in 1960, after all, we haven't told you anything about it changing, so that's a reasonable assumption to make, these terms will cross out too. And if those terms cross out too, you're left with, well, you had this 5 here, and you had, for the capital intensity, and you had this 900 here. So then output per worker in 2010 is going to be 5 times 900 is going to be 4,500. Same answer, gotten 2 different ways. One way is by saying we really don't know quite enough to solve any of these equations. But if we're looking at growth between 1960 and 2010, we do know enough to solve for what the growth is between 1960 and 2010. And we're given where things were back in 1960. Second way to do it is to say, well, we need to make an extra assumption. And since we're considering a universe in which the efficiency of labor isn't growing, assuming that G is 0 is a fine thing to assume. Either of those would be fine. 8b. 8b then. How fast has the efficiency of labor grown in Botswana over the past 50 years? Well, we've just calculated that if the efficiency of labor had not grown at all, Botswanian GDP per capita today would be only 4,500. It's actually 15,000. That's an extra growth factor of 3 1/3, right? 15,000 is 3 times 4,500. And that factor has to come from a growing efficiency of labor, right? We already took account of increases in the savings rate, et cetera, in saying that it would have been 4,500 if there had been no growth in the efficiency of labor. So that extra factor of 3 1/3 has to come from a growing efficiency of labor. Right? There is no place else it could come from. How fast does something grow if it grows to 3 1/3 times its initial value in 50 years? This is what God made the logarithm key on your calculator for, or the y to the x key. The logarithm key if you're an engineer, the y to the x key if you're an accountant. So you want something to grow to 3.33 times its initial value. That equation is 1 plus the growth rate raised to the 50th power. You take the natural logarithm of both sides, and then the nice thing about the natural logarithm is that if you have an exponential inside, the exponential simply gets pulled out to the front. In logarithm land, raising something to an exponential power is the same thing as multiplying the logarithm by the exponential power in front. Your calculator tells you the log of 3.33 is 1.203. That's equal to 50 times the log of 1 plus the growth rate g. And the other very nice thing about logarithms is that as long as your g is relatively small, as long as it's a percentage less than 20% or so, there's absolutely nothing wrong with simply saying the log of 1 plus g is equal to g itself. That's what the logarithmic function does as long as g is small. So you have 1.203 equals 50 times g, which gives you a labor efficiency growth rate in Botswana of 2.4% per year on average between 1960 and 2010, which is quite good, but actually not all that much faster than the United States. That in Botswana has been growing very rapidly, but not because it's been catching up a huge amount to the United States. Yeah?
Can you explain the part about just leaving it as g again?
As you mean, why is log of 1 plus g equal to g if g is small?
How do we know that g is small?
Well, if you found that your answer was g equal to 1, then you'd have to go back and say, wait a minute, I need to do this differently. That in general, if your answer says that g is less than 20%, it's fine. But if it's bigger than 20%, if it's bigger than 0.2, then you really shouldn't be saying log of 1 plus g is equal to g. And I think the intuitive understanding is the logarithmic function is related to the difference between compound interest and simple interest. And if your interest rates are small, there isn't much difference between compound interest and simple interest. And so there's not much difference between g on the one hand and the log of 1 plus g on the other. If you try to expand out, use calculus to expand out what this function actually is, you'll see that if you expand out the log of 1 plus g, you get a g, and then you get other extra terms that have g squareds and g cubeds and g to the fourths in them. And if you take any number that's a lot less than 1 and square it, it becomes really, really small. And if you cube it, it becomes really, 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 really small. So you can say if you used calculus to expand out what the function is, the idea that when g is small, log of 1 plus g is almost exactly equal to g comes immediately out of unpacking what the function is. A deep answer is this is the way the logarithmic function was defined. That if it hadn't worked out that way, we'd have thrown it away and chosen another function. Because part of making the logarithmic function useful is that log of 1 plus g is about g when g is small. It's just a tool, and it's kind of something you should have in the back of your minds. If you're engineers, at least, if you're accountants, you kind of do it a different way by using your y to the x key. Oh, okay. Let's see. Let me see if I can pull up the right program here. Yeah, here we are. Okay. Boing, 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 boing. Okay. What we have is we have 3.33. We want a growth factor of 3.33. This really isn't large enough. Big answer? Well, that's not much help. Preferences. Will preferences help? Appearance? Yes, yes. We can make our fonts bigger. Okay, hopefully that will work. And now let's get rid of the big answer. Well, that doesn't seem to have worked. Oh well, 3.33 was what you wanted to get. You wanted to figure out what the growth rate was going to be, that was going to get you, no, that's not what we want, equals 1 plus some growth rate raised to the 50th power. So the right thing to do then is, if you want to raise the growth rate to the 50th power, what you should then do is you should take the growth factor and you should raise that to the 1/50th power. And that's going to be equal to 1 plus your growth rate. And so then you can subtract 1, and that will give you your growth rate of 0.02435 of 2.435%. That is your equation back on nope, it's not there. Not there either. Not there. Not there. No, this is the right program, but the wrong slide, the wrong course. Right. Your equation was this 3.33 equals 1 plus g to the 50th. And in order to get rid of the 50 up there with your y to the x key, you want to take the left-hand side and raise it to the 1/50th power. That will, raising both sides to the 1/50th power, will knock out the 50, and then you'll be left with 3.33 to the 1/50th power equals 1 plus g, and then you just subtract off 1, and you get the growth rate. For problem C, asks you, what was the value of the efficiency of labor in Botswana in 1960? And once again, here I think there are two ways to do it, which are about equally good. The first would have been to say, what do you mean? I already did this for part A. We assumed that the growth rate of the efficiency of labor was 0. Then that means that this term is 0. We have 0.06 over 0.06. That means that E 1960 was $900. We already did this for part A. And that would be okay. The second thing would be say, wait a minute, we just did our calculations in part A, assuming that the growth rate of the efficiency of labor was 0, because that's what part A asked us. And then in part B, we found out that really wasn't quite true, that the growth rate of the efficiency of labor instead was 0.024, at least between 1960 and 2010. The problem doesn't tell us, but what if we assume that back in 1960, the efficiency of labor growth rate was the same as we turned out to calculate between 1960 and 2010? Then we have a 0.024 here for the growth rate of the efficiency of labor. And so we don't have a 1 for the capital intensity of the economy. We have a 0.72. And that means our efficiency of labor is $1,260 in 1960 rather than 900. That's a reasonable answer too. That's an answer we'd be very happy with. 900 and 1260 aren't the same, but they're not that different in the context we're talking about, which is the context between a difference between 900 and 15,000 for the relative prosperity of Botswana. So that's what we were looking for C. And then for D, what's the value of the efficiency of labor today? Well, we know what the value of output per capita in Botswana is today. It's 15,000. We already calculated 0.024 for the growth rate of the efficiency of labor. We have 0.3 for the savings investment share. We have 0.02 for the population growth rate. We have 0.04 for the depreciation rate. Simply solve those things together, and you get $4,120 for the efficiency of labor in Botswana today. That's a long problem. That's a hard problem. That's a problem that requires that you people say, wait a minute, I don't have quite enough information here. I need to make an assumption about the pieces of information I don't have. What assumption makes sense in the context of this model? I expected only about half of you to get it, but it looks like, as best as I can tell, only about a quarter of you got it. So think about this some more. Because this skill, the ability to do problems like this in the future would be actually a nice thing to have if you're ever trying to make sense of why some parts of the world are very prosperous and others are not. You have the ability to parcel out differences, either over time or across countries, between differences in the demographic burdens, in savings investment, and the efficiency of labor, is something we have to teach, and something you should learn. The other problem that I thought was going to be hard, and that did indeed turn out to be hard, is the France problem, right? Problem 10. That in France, population growth has been constant at 1% per year, and France is at a savings share of 25% per year, et cetera, et cetera. And France right now is a GDP per capita level of $35,000 per year. Assuming it's on and stays on its steady state balanced growth path, and assuming that efficiency of labor is growing at 2% per year, how rich is France going to be in 2050 and 2100? And how rich should France have been back at the end of World War II, back in 1946? Here, this just wants you to calculate compound growth. There's very little else to do for this problem. That is, French GDP per capita is growing at 2% per year. Today's level is 35,000 per year. Today's annual level of GDP is 35,000. Growth at 2% per year for 39 more years. Well, if we're accountants, we say 35,000 times 1.02 to the 39th as our growth factor gives us $76,000 a year as the average level of GDP per capita in France come 2050 if nothing goes wrong. Yeah?
Why is it 1.02?
Because it's growing at 2% per year. And in order to calculate compound growth, you take 1, you add to it the growth rate, which is 2% per year, 0.02, and then you raise that to the power of the number of years. That's what compound growth is. And the fact that it gets very large very quickly is an extraordinarily striking thing about it, and a reason that in general, when things are going right, we like compound growth processes, because they make things go righter. When things are going wrong, we don't like compound growth processes at all. So that's part A. On part B, same thing for 2100. Right? It's not 39 years away, it's 89 years away. 35,000 for the level of prosperity today. Growing at 2% per year, that gives us 1.02 for 89 years, raised to the 89th power. Will give us $204,000 per year of income for the average man, woman, and child in France come 2100. If nothing goes wrong with the pace of modern economic growth, of capital accumulation, of invention, of innovation, and so on and so forth. So that provided our people in Silicon Valley do their jobs, and provided the people in the class before us learning about immunology do their jobs and figure out wonderful biotechnology, and provided the people at Haas figure out productive business organizations to make applying all of this technology possible. Right? France is going to be really rich in come 2100 unless we've managed to nuke ourselves. Yeah?
You said that the GDP per capita is around 2% per year, but you said it was the growth in the efficiency of labor.
Yeah. Yeah. Well, that's how it's going to work. Right? That's one of the interesting things about the solo growth model. One striking thing about it, which is that once your economy's gotten to its balanced growth path, its capital intensity is constant. So that means this term stays the same, and this term's always the same, which means that if output per worker is going to change once you're on your balanced growth path, it's going to change only because the efficiency of labor changes. So that the growth rate of output per worker is the same as the growth rate of the efficiency of labor. At a deep level, this is true because if it weren't true, we'd have picked some other variable to call the efficiency of labor. All right? That it's nice to say that if an economy's growth is balanced, then productivity is growing as fast as the efficiency of labor is growing. But in this model, that's a conclusion that comes out of this model. And it's something that focusing on this equation allows you to assume and allows you to use, right? You know. So, yeah?
I'm not sure if this was the question, but you just said that you assume that GDP is growing at the rate of the labor force.
Well, that would be total GDP, right? That GDP per capita or per worker is growing as fast as the efficiency of labor is growing. But in total GDP, you don't just have more production per worker or per person, you have more people or workers as well. So the growth rate of total GDP is going to be equal to the growth rate of GDP per capita plus the growth rate of population or the labor force. Here we're asking about GDP per capita in this particular problem. So that's what we're focusing on. And the growth rate of GDP per capita, is indeed going to be the 2% per year. That's the growth rate of the efficiency of labor. Now we turn this around, and we go back in time. We'd say, what would France's level of GDP per capita in 1946 be if it had then been on today's steady-state balanced growth path? Well, today's level is $35,000 per year. 1946 is minus 65 years from now. So, and you can use the same equation used for growth in the future to project back into the past, only instead of going 89 or 39 years in the future, instead of having a plus 89 or plus 39 over here, you can put a minus 65 up here, and it works just as perfectly well. And you get $9,855 dollars per, or of today's dollars, as what the level of prosperity in France would have been back in 1946, back at the end of World War II, if France was then on its balanced growth path, with the efficiency of labor growing at 2% per year. And now we get Part 10D. In fact, in 1946, just after World War II, France was only about 30% as prosperous. We were sending them all kinds of emergency food and other aid in the immediate aftermath of World War II. And so the question is, why was France's level of GDP per capita back in 1946 so very low? Was it because the efficiency of labor in France in 1946 was really, really low, was much lower than our projection? Perhaps a little bit, but France has always been a relatively rich and relatively industrialized country for centuries. It's a standard North Atlantic economy that's been at the leading edge of global prosperity for the past 5 centuries. To say that France had an extraordinary burst of adoption of new technologies in the past half century just won't cut it. And then what's the other possible answer? Was it that France's capital output ratio was low in 1946? Probably. That's the answer I'm looking for, right? Saying that only 2 things could have made France poorer. The first is if the efficiency of labor was much less than this projection projects. The second, if the capital intensity of the economy was wrong. If the capital output ratio was much lower in 1946 because something had gone wrong into France's process of investment before then. What would that something be? Well, once again, here's the answer as to what went wrong with investment in France in the years before 1946. It's called Adolf Hitler. Right? Hitler invades and conquers France, along with Belgium, the Netherlands, Luxembourg, Denmark, and Norway in 1940, occupies France for 4.5 years. In the meantime of those 4.5 years, the U.S. Army Air Force bombs the hell out of France, destroying every single railroad bridge we can find, along with other things, in preparation for our invasion in Normandy in 1944. We then fight over France for about 6 months before the U.S. and British and the revived Free French Army disappear off the map into Germany. And so when 1946 comes along, France has been the battleground of World War II for a whole large chunk of the previous 5 years, either on land or during those years when the Nazis are occupying France from the air. That had an extraordinary, although temporary, impact on France's economic prosperity, to have been a battlefield. Okay, so that's the things that I want you to know from problem set 2 that you weren't getting. And to the extent that I don't get far enough to have a full problem set for problem set 3, I'm going to use problem set 3 to try to hammer these back into your heads once again. Other recapitulations. I don't have to teach you anymore how much bigger is total world GDP now than it was 10,000 years ago. You got this. It's 17,000, about 1,200 times bigger because of population, about 14 times bigger because of richer. Multiply those things together, you get 17,000. You know what the unemployment rate is right now. It's 9.4%, although tomorrow morning at 5:30 a.m. Pacific time, the Bureau of Labor Statistics will release its numbers as to what the unemployment rate was during the January survey, which took place in the second week of January. You got Say's law, that the reason that right now our unemployment rate is 9.4% rather than its normal 5% is because people spend their incomes not just on currently produced goods and services, but on financial assets. And right now, a huge number of people in our economy want to have more safe financial assets in their portfolios than they do. And so they've all cut back on spending because they think if we don't spend as much, we'll be able to take our extra savings and put them in financial assets. The problem is they don't recognize that if they don't spend as much, other people don't have as much income. And so other people are going to be unwilling to let go of their financial assets because their incomes have fallen. You got that nailed. What I want to see if you do have nailed is, once again, which is the growth equation that you all should have been using for problem 8 and for the other problems. If we hand you an economic growth problem, it's either going to ask you to do compound growth of one form or another, or odds are you're going to want to start from one particular equation, and you've got it nailed as well. So it should have found problem 8 easier then, to the extent you've gotten that much nailed. So let's see if you can actually do it on the fly again. And as I say, this is very hard, right? I've practiced giving myself 30 seconds and numbers that I don't know, I haven't known beforehand, to try to actually calculate it by hand without resorting to the pre-automated spreadsheets. And my median time to a correct answer is 45 seconds. That I can get an answer in 25 seconds, but the odds are less than 50-50 it'll be right. Here you've beaten me. You got 52% have the right answer, which is quite good. And last, the other type of growth question that I want you to be able to handle is really going to be a compound growth question. Right? What's the growth rate of GDP per capita in Zambia over the years since 1960? Okay. All right. And there we have a plurality for the right answer. Now, E can't be right because Zambia is poorer today than it was in 1960. And a positive growth rate would mean it was richer today than it was in 1960. So E can't be right. D can't be right because if something's shrinking at 6% per year, then the rule of 72 tells you that since 72 divided by 6 is 12, that it halves in size every 12 years. So if Zambian GDP were falling at 6% per year, and if it were $1,800 in 1960, well, it would have been $900 in 1972, it would have been $450 in 1984, it would have been $225 in 1996. It would be now $125 today. And since the World Bank's definition of absolute, desperate, total, complete, utter, on the edge of starvation poverty is living on $1 per person per day. That's $365 per capita per year. Pretty much everyone in Zambia would now be dead of starvation, if of nothing else. B, if something's growing at 15.7% per year by the rule of 72, it's doubling in size every 5 years. And if you start from 1800 and if you double every 5 years, there's no way you're going to be down at 1300 after 50 years. 50 years is 10 times 5, so you'd have had 10 doublings. If something doubles 10 times, it grows to be 1,000 times as big as it used to be. So that would be GDP per capita of 18 million per person in Zambia today, which is definitely not what we see. And 2.8% is, once again, we know it's shrinking, not growing. And a positive growth rate means it's getting bigger, and it isn't. So simply the plus minus should have narrowed you down to between C and D. And then thoughts about the magnitudes, about how quickly something shrinking at 6% per year vanishes, should have led you to hone in on C. I'm sure you'll do better next time. All right, now let me try to quickly finish up with the economic growth unit. It's pretty clear I'm not going to get into the depression economics unit, which means problem set 3 is going to be half of a half problem set, a 5-problem problem set. And then the rest of problem set 3 is going to go into problem set 4. As it said, we knew that modern economic growth started no earlier than 1800. How do we know? Because if it had started earlier, the world before 1800 would have been much poorer than the world in 1800, and it could not have been. That after all, when you're spending 70% of your income on food and only getting 2,300 calories a day, and yet engaging in pretty much in hard agricultural labor, you can't be much poorer and still survive. And the world back in 1800 was pretty equal, and the world today is not anything like equal across countries. We have extraordinary divergence over the past 2 centuries, even though as consolation we have some significant convergence since 1980 or so, some significant catch-up. And why did things get worse? Well, the big reason that things got worse during the middle parts of the century was the fact that communism ruled 2/3 of East Asia. And it's truly a theological point that Lenin, Stalin, Mao, Castro, Kim Il-sung, Pol Pot, Ho Chi Minh, all of them really believed Marx when Marx said that markets are ways of cheating the workers, and if you want to have a society that's fair, that doesn't cheat the workers, you can't have large-scale market exchange, and you can't have people getting hired by private businesses, that just leads to exploitation. If you get rid of markets, then you have a hell of a time figuring out how to organize the economy. And no matter how hard they tried, and they did try very hard, trying to organize an entire national economy top-down via central planning as though it's some kind of large collective war or dam-building effort just doesn't work too well, as shown most strikingly in the extraordinary difference in economic growth over the first generation of Maoist rule, the 33 years or so between the end of World War II on the one hand, and Deng Xiaoping's southern expedition and abandonment of central planning as an economic strategy at the end of the 1970s. Then, right, he wasn't stupid. He could look across the Straits of Taiwan. He could say that back in the 1930s and in the 1940s, these people in the Kuomintang were corrupt and fairly incompetent, and certainly not what we'd regard as very good rulers. So how come they've managed to do so much better on the other side of the Taiwan Strait than we have? They must have lucked onto some system that's better than ours. And he But things got worse between 1800 and 1980 or so for reasons other than that some countries had the bad luck to be ruled by people who believed what Karl Marx's strictures against the market economy. The first is demographic burdens. Poor countries are countries in which you're not too confident your children are going to survive to adulthood. Poor countries are countries in which people are going to want to have a lot of children because that's the only way of providing themselves with old age insurance, in the sense of having someone likely to be around when they're old who will be willing to take care of them, as opposed to throwing them into the ditch and passing on. What this means is if that a country has been poor over the past 2 centuries, it's had a higher growth rate of population, which means that a much larger share of its investment has to be diverted to simply creating enough capital to equip the new workers with enough to produce at the previous rate, rather than deepening the capital intensity of the economy and so raising productivity. We see this mostly, I think, most strikingly in Egypt. Right? That Egypt in 1800 had 3 million people in it and was quite poor. Egypt today has 81 million people in it. Population growth at a factor of 27 over 2 centuries. And it's not as though Egypt has an awful lot of land to farm. Right? What land it does that you can farm is very good land. You have millions of years of organic silt brought down from the highlands of Africa by the river Nile. Right? That the Nile Delta and the Nile Valley is incredibly fertile and prosperous agricultural land. But there isn't that much of it, and there was barely enough of it for 3 million people in 1800, and now there are 81 million people, and so over the past 2 centuries, right, Egypt, without a huge amount of natural resources, has had to divert a huge chunk of its investment to trying to find ways to support all those extra 78 million and get them jobs, which it's done okay at. Not great, but okay. But that's a reason. That's a reason why high population growth countries are relatively poor countries today. Why did things get worse? Too? Investment. Countries that invested a lot seem to do significantly better. And countries that invested were rich had a much easier time investing a lot because if you're a rich country already, that means you're relatively good at making machines, that machines are cheap in your country. And if machines are cheap in your country, then if you divert a little bit of spending from private consumption, you get a whole lot of investment goods for that diversion. By contrast, if you're a poor country, that means that machines are expensive. And so even a large diversion of resources away from consumption gets you relatively little in the sense of extra useful capital equipment to amplify your productivity. So if you're a poor country, you have a very hard time matching the savings effort of the rich. And so that makes economic development extraordinarily difficult. Those countries that have done it, best, have been places like South Korea that have opened themselves up to imports of manufactured machinery from the industrial core. That even when the South Korean government was most interested in nurturing domestic industries, it said that if you're a growing domestic industry and you want to import a piece of machinery from elsewhere in the world, you can do so tariff-free. In fact, we'll give you a subsidy to do so. Because we know you need machines more sophisticated than we can make here at home yet, and we really want you to have those extra machines. But differences in population growth rates, in the fact that you haven't yet gone through the demographic transition by which population growth drops if you're poor, and differences in relative price structures, they're smaller than differences in the efficiency of labor, differences in technology and organization. Even within market economies, most of the action in international inequality is differences in the efficiency of labor worldwide. And here the things get difficult. Because to get a high efficiency of labor, you need to have the government build and maintain a lot of infrastructure. You need to educate your people. And when people are poor, it's very difficult to educate them. And even when people are rich, it's kind of hard to induce relatively young people to spend an awful lot of money on education, especially if they're worried about their potential student loan debt. Like, is there anyone here who thinks they're going to graduate from Berkeley owing more than $50,000 to the student loan vendors? Okay. 25,000? Okay, that's sizable. 10,000? Okay. For practically all Americans, aside from those who are children of the upper middle class, if you graduate from college with less than $50,000 in student loan debt, you're lucky. And a lot of people aren't willing to take on that kind of debt burden in an uncertain future, even though we economists say, look, given your skills and given the likely complexion of the future, you could easily pay off that $50,000 in less than a decade with your extra earnings. That means that a large educational effort also has to be financed by the government. And so in order to get the infrastructure and the education, you need an honest and competent government. And an honest and competent government, well, you need it as well for other reasons, too. If you don't have an honest and competent court system, then pretty soon people are going to be turning their attention from figuring out how to make things more productively to figuring out how to gain political influence so they don't get their money stolen from them through illegal or legal process in some way. And you'd like to have talent directed toward positive sum rather than negative sum entrepreneurship. You'd rather have people like, say, Bill Gates interested in getting rich by writing software and selling it to people so their computers can do more things than people like 12th century William Marshall, who wants to get rich by figuring out how to stick people with spears while riding a horse, and then extract 1/3 of the agricultural produce of the earldom of Pembroke for himself and his knights, simply because they have horses and spears and the peasants do not. A society in which your talented and aggressive people learn how to stick other people with spears is going to be a less productive one than one in which they write software. You've got to direct your talent toward positive sum rather than negative sum entrepreneurship. And how do you do that? Especially if you start out 1800 as a relatively poor economy, a relatively poor region, which isn't already in the industrializing North Atlantic web. And over the past 150 years or so, there have been about 5 different theories of what should be done for economic development. And the first one, the old days, was imperialism and colonialism. That there are some countries that are more advanced and others that are less. And the more advanced countries should conquer the others and should teach them, like older brothers teach younger brothers, et cetera, how to become rich and prosperous and civilized. This is why school children in the Côte d'Ivoire, in the Ivory Coast in 1946, were being taught how their ancestors, the Gauls, resisted the attacks of Julius Caesar at the fortress of Alesia in central France back in 52 BC. So there was the great wave of European imperialism. There was then considerable excitement for central planning, especially given the statistics released by the Soviet Union in the 1930s, 40s, and 50s about the Soviet industrialization experience. Then there was a wave of enthusiasm for focusing on infrastructure, on having the World Bank build ports, railways, dams, and development guided by the government. You then had a belief that you should follow import substitution, that if countries let themselves specialize in the goods and services where it appeared to be easy to export, that poor countries were trapping themselves into making low-value agricultural products and would never acquire the technological know-how they needed to become rich. And last, there was the bet that I was a part of, the bet starting in the late 1980s, that something called neoliberalism was the right road. to economic development. And the politics of this doesn't always wind up the way, or didn't always line up the way you would think. For example, here we have an unexpected advocate of colonialism, right? Someone who talks about the conquest of India by Britain, and how, yes, it was bloody that the British imposed political unity by the sword, but now at least the peasants don't need to worry about getting killed by marauding Maratha bands coming in from the south. We have some talk about natives, but the talk is about how the natives are springing up, or out of the natives are springing up a fresh class of effective administrators, engineers, and how steam power has greatly shrunk the communication distance between India and Europe. About how the ruling classes of Great Britain conquered India just for their own selfish purposes, because they thought it was a way to get rich, either through plunder or through markets. And yet now, in the process of figuring out how to exploit the Indian market, they've built a network of railroads across India. And this is going to be the source of an absolutely magnificent economic transformation. And our advocate concludes, praising the Hindus for their aptitude for accommodating themselves to new labor and acquiring the knowledge of machinery, and saying that one impact of the coming of modern machinery and the modern division of labor is going to dissolve the Indian caste system to its great benefit. And this guy is Karl Marx, writing in The Future Results of British Rule in India, the New York Daily Tribune, on August 8, 1853. That colonialism has been extremely bloody and brutal for India, but is in the long run, Marx said, likely to be the very best thing to ever happen to it, which would kind of get him stoned in virtually any Indian city today were he to stand up and say this. He looks to have been wrong. Right? That is, it doesn't look like the British colonization of India did anything to boost its rate of economic growth or development. That whatever good was done by railroads and infrastructure and ports appears to be offset by bad done by overturning landed property institutions the British did not really understand. And whatever good was done by bringing machines into India was offset by the fact that the British government was totally uninterested in education. That you look at similar countries in Asia that remained independent, of which there really were only two, Japan and Thailand. And both Japan and Thailand appear to have done significantly better during the colonial era. Japan magnificently so. So we gave up on imperialism, colonialism. Central planning. It is certainly true that central planning in the Soviet Union in the 1930s created something that turned out to be uniquely valuable to the world come 1941 and World War II. That is, because Joseph Stalin was running a centrally planned economy, he built huge tank factories on the far side of the Ural Mountains as far as possible from Germany. And so even when the Nazis had overrun most of the populated regions of Russia, Russia's tank factories were still there building tanks. And certainly true that a market economy would have located all the tank factories near the border. And so that our collective Allied victory in World War II probably owes a lot to the fact that Stalin's central plan was to build lots of tank factories and to build them far away from the border. That aside, central planning really doesn't have much to recommend it, neither in the Soviet Union nor elsewhere. And in fact, Alexander Gerschenkron, who was the dissertation advisor of one of my dissertation advisors, Peter Temin, and who started out his U.S. academic career here at Berkeley in the 1940s. He pointed out in the late 1950s that practically all of the statistics released by the Soviet Union about its own industrialization experience proved to be wrong, or at least severely misleading. The idea that the World Bank would invest in infrastructure and that would make poor economies rich, or that governments would guide development to underdeveloped regions, didn't seem to do very well either. Import substitution, right? The idea that you should put high tariffs on imports of machinery and build up your own kind of heavy manufacturing industries, proved to be a complete disaster. Like in Argentina in 1970, you had 8 different automobile manufacturers, none of which could manufacture at anything like an efficient scale. So by the end of the 1980s, having seen 4 successive waves of ideas about what development policy should be fail, the world, or at least the great and good of the world, or at least the powerful in the world, turned toward this thing called neoliberalism. And the belief was that if you're a poor country, especially if you're a poor country with lots of natural resources, it's going to be almost impossible to keep the government from becoming highly corrupt. So the best thing you could do would be to shrink the corrupt state and then to encourage as much international trade as possible. Because as much contact as possible between poor countries and rich countries would at least put people in touch with people who understood how to use technology. And you could get a lot of technology transfer out of that. The other thing that turned out to be important to do was to provide entrepreneurs with access to credit and to build social capital, especially through female education. And kind of send all your children, especially the girls, to school for as long as possible. And these 4 sets of policies. Open borders to encourage international trade, downward pressure on the size of states and how much of the economy they controlled, market access to credit, and building social capital, especially female education, were collectively supposed to be the magic bullet to lead to faster development. Unfortunately, shrinking the state ran into building social capital. You really can't do both, since private markets don't do a very good job of boosting education. It's hard to get people to invest that much for that uncertain future. So these 2 initiatives largely cancel each other out, or this one managed to kind of negate this. And if a government's corrupt, is there any reason to believe that if you make it privatize its water company, it won't do so in a corrupt and inefficient way? That asking a corrupt economy to run an honest auction in order to privatize state enterprises is asking for real trouble. Encourage international trade. We have an argument over whether that would have been much better than it has been if not for the rise of China. That is, that the rise of China as a world exporter has kind of crowded out a great deal of the space that 20 and 25 years ago we thought would be occupied in the world division of labor by countries like Mexico. And so a whole bunch of factories we thought would be located in Mexico today are instead located in China. And so the benefits to Mexico of something like the North American Free Trade Agreement that I worked on have turned out to be much less than I was confidently predicting back in 1992. Microcredit, all right, the Grameen Bank and other initiatives to give people with ideas access to money to turn the ideas into good things appears to be the one big win of the neoliberal agenda, but only on a very small scale. This, too, did not turn out to be the magic bullet. And so we confront the second decade of the 21st century without any terribly good ideas about how to speed the pace of world development, other than to tell countries, look at what East Asia is doing, look at what Western Europe did in the generation after World War II, even look at India right now. They're clearly doing something right. So what did you get out of that 12-minute gallop through comparative development economics, through what should be done to kind of reduce the great global inequality across countries that we now see in our world? Here, I don't think there's an especially right answer. I believe in some answers more strongly than others. Yeah, that is, I tend to think D is important. But, E is definitely important as well. There's an argument for C, on the grounds that unless you have a high investment economy, you're going to have a very hard time raising your efficiency of labor. Because if you look at any single enterprise, you see a huge chunk of knowledge of new technologies is actually embodied in machines. And so you need to invest in those machines to get the technology. And then there's even an argument that you need to export to the first world to be able to afford to buy the machines that will get you the higher efficiency of labor. And it's certainly the case that if you don't go through the demographic transition, you'll wind up poor, but virtually everybody is already, that there seems to be no great need for policy to boost that. So I'd say D is probably the right answer, but this is a matter of opinion and debate. The other half of the future of economic growth isn't how do you get the poor countries of the world to kind of catch up to the North Atlantic, but how do you keep rapid economic growth going in the North Atlantic industrial core? And it's very much the same, right? That to get a higher efficiency of labor, you once again need infrastructure, you need education, you need honest government, you need talent directed in positive sum directions. But if you're already at the world's leading technological edge, you need not just how to figure out how to adapt technologies invented otherwise for your conditions, but you need invention as well. And how do you get that? Well, how do you spur research and development? Well, you have to have basic research to figure out what the underlying scientific principles are. You have to have applied research to figure out what actually the basic research allows people to figure out how to do that's useful. You then have to have interfaces between the technologies and the human beings who are actually going to use it. So people on the factory floor or wherever can actually make use of the products of research and development. You need marketing to convince people that they really ought to use this brand of computer or this brand of numerically controlled machine tool, or they should take 2 tablespoons of flax oil every day for general omega-3 health or whatever. And you also face a bunch of potentially conflicting considerations. There's the idea that you want to avoid free riding. You want to avoid too much copying by some people of the work of others, because if everyone knows their work is going to be copied, they're going to have a big incentive not to work too hard on it, to try to figure out how to gain profits from it, rather than to figure out how to advance technology. On the other hand, you want to have people able to stand on the shoulders of giants. Right? This was Sir Isaac Newton's line, that if I have seen farther than other scientists, it is because I have stood on the shoulders of giants. Very good line. Means that we genuinely like things like open source software that allow the scientific and technological community to use whatever's been developed before. And then there's stepping on toes, right? That does it really make sense to have 8 different companies trying to start the same kind of social network and competing with each other and making their social networks incompatible with each other until Facebook wins and everyone else surrenders? How much resources are wasted in that? To try to resolve these issues, we have systems of patent and copyright laws. We have systems of antitrust laws, and in Europe what they call competition policy. And we have a very diversified institutional portfolio here in today's world, ranging all the way from government-sponsored institutions like the National Institutes of Health to nonprofit, largely research organizations like Rockefeller University or UC Berkeley, on up through, say, for-profit companies, and then selected loose groups of human beings organized around a charismatic leader like Wikipedia around Jimmy Wales or Linux around Linus Torvalds. And the big conclusion seems to be that a diversified institutional portfolio seems to be best. And the question is, how do we keep our institutional portfolio for research and development properly diversified going into the future? And that's a question. I don't have an answer to it. There are people up at the Haas School who think they have an answer. There are people at the Information School who think they have an answer. I have a second cousin, Tom Khalil, who used to be here at Berkeley, who's now special assistant to President Obama for technology. He's supposed to have the answer. I'll talk to him over the weekend and tell you on Tuesday what he thinks. And let me stop there.